Morning, 7th grade. This screencast is to explain to you what a Punnett square is and to get down some vocabulary from the heredity and genetics unit. So what you're going to need to do after I pause this is turn to pages 158 and 159 of your notebook. So make sure your book is open to both pages. On page 158, you are going to write down Explaining Mendel, Punnett squares on the top of that page. And on the top of page 159, you will write down heredity and genetics. And I'll pause this to give you guys a chance to write that down. Okay, so what I want to do is revisit what we learned about Mendel yesterday. And if you can remember that Gregor Mendel had all that free time on his hands breeding pea plants, and he noticed that the plants were either tall or they were short. So he had one field that was filled with tall plants, he had one field that was filled with short plants, and he decided to see what would happen if he bred them together. Okay, so he took what we called yesterday pure tall plants, and he bred them with, and that's what that little X means, pure short plants. Okay, so if you guys will remember from yesterday when we talked about how Mendel discovered that for each trait that he was studying, there were two factors. He called those factors alleles, and yesterday at the end of class we said that tall was dominant over short, and we wrote down their genotypes. Okay, so capital T is an example of a genotype. Let me spell that right. And little t is the genotype for short. Now, the observable trait yesterday in class we referred to as a phenotype. So tall is a phenotype and short is a phenotype. Okay, so what we're going to do now is go to page 159, because 159 we're going to list all of our vocab from this particular lesson. So one piece of vocab was the pure or purebred. Okay, a pure or purebred is when an organism has two identical genes, sorry guys, my spelling is terrible, identical genes or alleles for a certain trait. Okay, now remember we represented genes with letters. So an example of purebred would be capital T because they're two dominant alleles, or lowercase because they're two recessive alleles. So we'll talk about dominant and recessive again in a minute. So the second term we mentioned on page 158 was a genotype. Okay, and when you talk about a genotype for a particular trait, it's just the genetic makeup. What genes? So the genotype for a tall plant was capital T. Our genotype for our short plant was little t. Okay, and then finally the word phenotype. Okay, a phenotype is a physical characteristic. Characteristic. It's a big word. Okay, and I want you guys to remember that phenotype and physical both start with PH, so it kind of helps you remember the definition. And an example of a phenotype would be tall. It's what something looks like, what you can see with your eyes. Or the pea plants were short, or the flowers were purple, or your eyes are brown. Okay, so all those things are examples of phenotypes. Okay, so let's go back to page 158 because I think those are the three definitions that we've come across so far. Okay, all right, now back to what we talked about with Mendel yesterday. So he had these tall plants that were pure. They were always tall, gave you tall, gave you tall, gave you tall. Had a field of plants that were short. Short plants gave you short plants, gave you short plants, gave you short plants. And he wondered what would happen if you bred those together. He thought maybe you would get medium-sized plants, and he was really surprised when he found out that when he bred those two plants together, a pure tall and a pure short, he didn't get medium-sized plants. He got plants that were all tall. Okay? A shocker. He called those plants, if you remember from yesterday, hybrids. Okay? Hybrids to him were a mix of two different phenotypes. Okay? So I'm going to tell you guys that the genotype of those tall plants were capital T, lowercase t. Okay? Now we're going to go back because we've added the word hybrid in. So let's put that word in our list on page 159. A hybrid. Okay? A hybrid is a plant that's not pure. It's got two different genes or alleles. Okay. So when we talked about the hybrids, we said that their genotype was capital T, and that's what I'm trying to write down right now, was capital T, lowercase t. Okay. Now there's a second word that I'm going to be using much more often than hybrid, and that word is heterozygous. Okay? So instead of calling a particular genotype a hybrid, okay, meaning it has two different genes, it's got a dominant one and a recessive one, and we're going to add that to our list in a second. We're going to instead say that it's hetero. Hetero means different. It's heterozygous, which means that, what do we call these purebred genotypes? If both of the genes or alleles are the same, if hetero means different, homo, like homogeneous, means the same, so we call that homozygous, okay? So this is really the vocabulary word that we'll be using in place of homozygous in place of purebred and heterozygous in place of hybrid. Okay. So I mentioned recessive and dominant. Let's get those terms down too. They're pretty important. So remember yesterday that we said Mendel noticed that the tall trait seemed to mask the recessive trait, okay? So recessive gene or a recessive allele, it's an allele that is masked by a dominant. Like the tall allele masks the short when they're together, okay? So then that means recessive. Let's use the, we use dominant in the definition for recessive, so now we're going to use recessive in the definition for dominant because we're tricky that way. And a dominant gene or allele is an allele that is masked, that masks a recessive. Like tall was dominant over short. When you put them together, tall wins, okay? Next vocab word, I keep using that word allele in definitions, okay? Allele is just a different form of a gene. So you can kind of use the word gene and allele almost interchangeably, but not quite, okay? So the allele for tall is a capital T. The allele for short is a lowercase t, okay? All right, so that does it for definitions for now, I think. I don't think we have any more, but maybe we will. All right, so let's go back really quickly to Mendel's story. So he was really, really confused. Why did he get all tall plants? Where did the shortness go when he bred those pure tall with the pure short? So he was a pretty smart guy, and he decided he was going to breed two hybrids together. Okay, so breed those two tall plants. And when he bred them, if you guys remember from yesterday, he got a really surprising result. He found out that no matter how many offspring he produced from that, breeding the two hybrids together, he got 3 tall plants for every 1 short plant. So the shortness came back, but it always came back in that proportion. So how did he explain that? Well, he was mathematical, so he realized that in order to explain that, he could use a little math. Now today, we explain that by doing something called a Punnett square, okay? A Punnett square is a little mathematical shortcut that gives you all the probabilities of offspring that 2 parents can have. So when you're doing a Punnett square, it is a square. That's why it's called a Punnett square. So we start off by drawing a square. So we're doing something called a Punnett square. Okay, I don't know why my computer's being so weird. Okay, so I think what I'm going to do, since my computer is not behaving really well, is I'm going to end this screencast now, and then we'll do the Punnett square together. Okay, so we have all of our notes, we have our definitions, we reviewed what Mendel's results were from yesterday, so now we can get together and learn Punnett squares together. Okay, let me end this screencast.